Hi, today we'll be doing this Calc 1 problem, and we're given a velocity function in meters per second, and we know the initial condition that at time equals 0, the object is at 3 meters. So we're asked to find the position function, acceleration at time equals 0, and the total distance traveled in the first 3 seconds. So first of all, we'll start with the position function. And so to find this, we know that the position function equals the integral of the velocity function. So when we plug this in, so now what we can do is just take the derivative, which will be t2 plus et plus a constant. And then to find that constant, we'll use the initial condition that we are given. So s when t equals 0 equals 3. And then using the equation we just found, we can sub that in. So that will be 0 to the second power plus e to the 0 plus c. And then we can rewrite this now as 3 equals, and then e to the 0th power is 1 plus c. So we know that c equals 2. So now we can rewrite our equation. So the position function equals t squared plus et plus 2. So there's the first part done. So next we're asked to find the acceleration function. So to do this, we'll be taking the derivative this time of the velocity function. So just rewriting this out here. And then when you take the derivative, you'll get 2 plus et. So this is the answer for the acceleration function. So we're asked to find the acceleration at time equals 0. So we can just sub that in. So t equals 0. And then we have our acceleration equation. And then, so this will equal 3, and then meters per second squared. So the last part we're asked to find is the total distance traveled in the first 3 seconds. So you can say that the integral of the velocity function will give you the displacement between those 2 time periods. So first of all, we need to make sure that our object is not moving back and forth, changing direction, because then it won't be the same as the total distance traveled. So we can look at our equation up here, and just by looking at it, we can tell that if t is any positive number or 0, it will have a positive velocity. So with this observation, we can just say this displacement is equal to the total distance traveled. So we can just solve it like this, and subbing it in. And then when we integrate that, we did this prior, t squared plus et, 0 and 3. So then what we end up is with 3 squared plus e3 minus, and then 0 plus e0. And then when you put this in the calculator, you get 28.1 meters. And so we found all our answers, and I hope this helped.